Basically, I have the pleasure of introducing a lot of people. I've done this a lot over the years. My greatest pleasure is introducing someone who needs no introduction. So I'd like to introduce you to a man who needs no introduction, Bob Katz. If you don't know who he is, just Google him.
Hi, everybody from all over the world. So I want to start by saying congratulations to the Audio Engineering Society for the Technical Grammy Award and also for all the Grammy winners. Folks, we are on SessionWire, which is in early access at this point, but it seems to be working really, really well. And what I'm going to do to start off with is play a recording that I mixed for PBS in 2021. It's the 2021 performance of the Knoxville Jazz Orchestra Christmas show, and I mixed it in November of 2022, and it was broadcast in December. Let's hear a little piece of Sleigh Ride by the Knoxville Jazz Orchestra, mixed by me in 2022. So I mixed that in 2022. Now I'm going to play the climax. We're hearing 4 trumpets, 4 trombones, 4 saxophones, and the rest of the band all playing at quadruple forte into condenser microphones, mixed by me in 2022. So let's hear the ending of Sleigh Ride from 2022 once again. Okay, now I'm going to go back actually to 2019 and we'll play the tail of the mix that I did in 2019. And I'm going to go back and forth a couple of times. So 2019, 2021. Okay, so let's see what 2021 sounds like in the big climax. Here we go. Gary, did you notice a difference, or did anyone in the chat notice a kind of a tonal or character difference between the 2021 recording and the 2019 recording? Anyone? More depth in 2022. Interesting. What about a tonality or distortion, if any, difference between 2022? Let's play it again, okay? I won't, the screen is shared. So this 2 here is the 2021 mix, and this 3 here is the 2019 mix. Okay, so once again, I noticed somebody in the chat saying that 2022 is more open, brighter, and clearer. The compression in 2019 is a little bit pumping. That's interesting. Somebody says, from a tonal perspective, I find that 2019 sounds weird. I'm not exactly how to describe it. Remember the topic of my talk today? Right. Digital versus analog processing. So here I will play once again the 2021 analog. Let me see some feedback in the chat. Very confused. Confused because you're not sure what you're listening to? Something beyond the compressions. Okay. Now somebody asked if all settings are identical for both analog and digital compression. Okay. I did say in an introduction that what we're doing today is some soft science and a lot of listening. These are 2 different performances. Same band, same microphones, same preamps, different processing. Hey, the temperature and humidity are different. Same mix engineer. All I can give you is my impressions and the band's impressions, and you guys can fight out whether all things are equal or not. I can tell you what I conclude from it, and I can tell you what the results are, and then you can argue over whether it's fair or a fair comparison or not. Okay, fair enough? In 2019, I used digital processing, and I did my best to try to create a warm, spacious presentation, and I really wasn't that happy. I thought it sounded harsh and a little bit fuzzy, really not that great in 2019. The band and the producer were very happy with the results, but I still felt there was more that could be done. In 2021, for the 2021 performance in 22, mix, I used analog compressors for all the processing, not a single digital compressor in use. The band remarked, the producer remarked, and I remarked that it sounds easier on the ears, warmer, and sweeter. Now, whether you're willing to believe the same amount of compression, all that other stuff, I'm just telling you how I feel about it. Now, before we move, no, not even a digital limiter, just digital plugins for the, what do you call it, for the 2019 and analog processing for 2022. Now, let me look up in the chat here to the previous comment. There's something beyond the compression here. 2022 sounds better. Thank you, Aaron Gandia. Aaron is one of my mix engineers. It says 2022 sounds better. What's better about it, Aaron? Were all the parameters identical? As I said, how can I guarantee the parameters are identical? I mixed in 2021, and I mixed again in 2022. All you can do is give it general compression. Okay? Now let's see if there's another comment. Laughing out loud, who knows why. Donald Jones says analog sounds fuller and less squeezed, more air. Aaron Gandia says it sounds better. Well, I'm personally convinced that the analog nonlinear processing sounds better than the digital nonlinear processing. But let's see if we can come up with some objective measurements that might correlate with the listening experience. Okay, the tricky part, it's not the same performance. Yeah, it's not the same performance. It makes it difficult to, for scientists in the audience. It's not a single variable test. It would be almost impossible to do a single variable test on this. It would take ages to match it up and set it the same. I could go on and on about that. All right, so let's talk about analog versus digital processing in the objective domain. Okay. This is when you saw me, I was facing my one of my racks, and let's just take a brief video tour of the front of my analog processing rack. Okay, there it is. Moving along, and moving along here, and we'll concentrate on the ATS1, the Animod ATS1. Anyone familiar with Animod at all? Oh, thank you. You should see the rest of my racks. Anyone familiar with Animod? Oh, yeah. Thank you, John. John is familiar with Animod. All right. The co-inventors of Animod are Dave Amels and Greg Gualtieri. But what Dave Amels contributed to a great extent were measurements of the transfer functions of a whole bunch of tape recorders, the nonlinear transfer functions. And he first employed those transfer functions as plugins for Pro Tools, and his company was, if I'm not mistaken, the Bomb Factory. Okay, so all those transfer functions went into plugins. Then he got together a couple of years later with Greg Gualtieri and decided, for reasons that I think you're going to understand in a few moments, to make an all analog tape simulator using analog multipliers to achieve the identical transfer functions of plugins. So that's the basis behind the ATS1, input, output, record, tape machine, 4 different tape machines, 4 different tape formulations, speed. I think this is my subjective opinion. I think the only thing missing from this, besides the hiss, which I usually leave off, and the wow and flutter, is maybe the smell of capstan oil and grease and ozone from the motors. I think it's that authentic. Okay, so now what we have here is a measurement at 96 kilohertz of the anomod in my rack. It happens, though, that the sample rate doesn't matter because it's an analog processor. So these measurements that you see here are constant regardless of the sample rate. And I put in 1 kilohertz at 0 VU, which was, I think, 250 nanowebers per meter, emulated. You can see 60 hertz hum, 180 hertz, bunch of little hum and noise products, and actually a noise floor, which is not incredible, but not terrible. And here's second harmonic, third harmonic, fifth harmonic, seventh, ninth, and 11th. That's what we get. All right, so now below this, I'm going to show you at the same sample rate a digital plugin that also emulates analog tape. Oops. What we have is a much quieter noise floor. None of that hum, which is, I guess, nice. Second harmonic, much higher than it is in the anomod. Third harmonic, much higher than it is in the anomod, at the same simulated fluxivity. Fourth harmonic, fifth harmonic, sixth harmonic, seventh, eighth, ninth, 10th. Oh my gosh, all the way up to 30 kilohertz. And then there's some kind of a knee here that I think is some kind of filtering, and there's still more garbage all the way up to 40K. Now, in my opinion, and again, this is subjective opinion, but maybe the objective measurements kind of give you an indication. The digital plugin sounds fuzzy. The analog simulator sounds open, clear, transparent, and very much like a real tape recorder. Because, you know, tape decks are not as fuzzy as you think if you run at 15 IPS at 250 nanowebers per meter with GP9. So that's an indication. Now let's send 19 and 20 kilohertz into the anomod. We don't see any difference product unless there's that 1 kilohertz that's down there is a difference product. There may be a difference product there, but it seems like what we have is a little touch of 18 and 21 kilohertz due to some kind of intermodulation. John Chester probably could tell me right away where that comes from. Okay, now way over here we see the second harmonics of the 19 and 20 kilohertz showing all the way up at 40K. Okay, now let's put the 19 and 20 kilohertz signals into the digital plugin. Oh my goodness. What we see here is you got a big difference product, which means that any multiple frequencies mixed together in this plugin to produce difference products. Then the difference product, which is 1 kilohertz, produces its own harmonic distortion at 2, 3, 4, 5, 6, all the way up again. And there's tons of other intermodulation here. All right, so that's evidence number 1 in the objective domain. What do you think that this kind of thing would do to the sound? The plugin may have a low-pass filter starting around here based on my evidence here, Bob Olson. There may be a low-pass filter going on. But what do you think that this kind of distortion would do to the sound quality of this particular digital plugin? Because we're at 96K. So I think what we're seeing is mostly just intermodulation distortion, not aliasing with a sample rate. I don't have an example showing the plugin at 44.1 kilohertz, where the aliasing would be more obvious. I'm going to answer my own question and say I think that this kind of symptom produces harsh quality and fuzziness. Now, John Wilkinson asked, my question is, this poor software, are we extrapolating this to the greater whole of software tape simulators? The answer is, I have not yet found a plugin that does analog tape justice. This is one of the worst that we're looking at, though. Now, what we have here is the actual analog processor that I used for the 2021 mix. It's from another extraordinary DSP developer, Colin McDowell of McDSP. Colin is very well schooled, and he came up with a real, I think, thinking outside the box, just like Dave Amels did for the Animod. Colin built a box with 16 channels of D to A conversion, 16 channels of A to D conversion, and in between, digitally controlled analog processors. And the plugin that I chose is to show you here is the APB MooTube. Okay, so we get a little bit, this is his tube emulator in the analog domain. And it's a compressor. A little bit of difference product, harmonics of the difference product, plus some intermodulation between the 19 and 20K. Now, above this is a plugin that emulates the LA2A using the same test signal, same amount of gain reduction. And I'm not going to make any comments. I'm just going to show you these are aliases of the sample rate. We are at 44.1 kilohertz for this one, so it does do better at higher sample rates. This is an alias, this is an alias, alias. And some of these are aliases and some of these are harmonics of the 1 kilohertz difference. But look at this. Again, fuzz and harshness. And I think that translates to the brightness, the kind of brightness that you heard. Now, I didn't use this plugin in 2019. I used a different digital plugin, but look, 4 trumpets, 4 trombones, 4 saxophones, all playing at quadruple forte. You can imagine the intermodulation that occurs through that other digital plugin that I used. So, caveat emptor. That's my last comment here. Now, how do we beat the aliasing issue? Different ways. The first one is like the MIC DSP or like the Anamide ATS1. By the way, as a disclaimer, no disclaimer, I do not. I bought both of those products. So if there's cognitive bias going on, it's the cognitive bias of having put money into it, not that it was given to me free or anything of the sort. Okay, so how to beat the aliasing issue? Use nonlinear analog processing instead of nonlinear DSP. And if you use something like the MIC DSP, you can have digitally controlled analog processing, which gives us the ergonomic power of plugins with the purity of analog processing. But if you're going to use DSP, it's highly suggested that you upsample, which reduces the aliasing. However, and I ask this question, how much upsampling is necessary to please sensitive ears and avoid the harsh and fuzzy sound quality of aliasing? How far do you have to upsample? I think pretty far. Maybe 4 times, 8 times. I'm not sure. I haven't done the A/B. All I know is these days I don't take any chances. I try to stick with analog nonlinear processing until I don't ever hear a difference in tonality and purity of tone. Folks, another trick, a really incredible trick to reduce the aliasing is to use a band split. For example, let's say you have a 3-band compressor and everything above maybe 10 kilohertz is in the top band. That means that high frequencies in the material that cause aliasing will be, that aliasing, any aliases below 10 kilohertz will be filtered out by the 3-band compressor. So that's a very, very good way of avoiding aliasing, is to use multiband compressor in the digital domain. Another one is, when using DSP, try parallel compression or parallel processing. And I'm reminded of Ray Dolby's design for the Dolby A, which was a dry path mixed with a low-level compression path, because he wanted as few artifacts as possible. So parallel compression, if I mix the dry signal with the so-called wet compressor signal 6 dB down, say, that's going to reduce the distortion by 6 dB as well. That is the end of my talk. All right. So questions from the floor about this topic, what you heard, whether you feel or disagree that the listening examples that I gave at the beginning kind of maybe correlate or do not correlate with the measurements. What do you think? We got a little time to discuss.
I don't know if you dealt with this question already. I was a little distracted by the YouTube feed. Recording Geek asked, if the IMD test source is analog, is there a chance that some of what we see is AEA converter artifacts?
No, absolutely not. I'm using a digitally generated test signal fed into Pro Tools digitally, goes through the plug-in or the external analog processing, and comes back digitally into the analyzer. And it's dithered for the analysis. I dithered prior to the feedback to the analyzer, because there's a 24-bit truncation at that point.
I see another question here. I'm a big fan of multiband parallel processing, and indeed I got the idea from the design of Dolby A. I guess that's more of a comment than a question.
No, it's an excellent comment. I think that Ray Dolby had the right idea in mind to make any potential artifacts of the compression be as invisible as possible. instead of using an overall downward compressor. Now, I think when they moved to SR, they did a different approach, but I don't remember the SR schematic, so I can't say 100%. But that was the Dolby philosophy. You all have seen the case. I've made my case, given you my subjective opinions and some objective measurements that might support the conclusions, and the rest is up to you guys. At least be cautious. Forgive me for chiming in again. The noise level here is so low that any distortion artifact is lower than the noise for the other tool. Am I off base? John, to be able to decide how audible some of these artifacts are would require some very, very careful double-blind tests, a lot of careful listening. There are a few psychoacousticians who could come in and tell you whether this amplitude is audible and this amplitude isn't. I can only go by my ears and my reactions. And I can tell you that a double-blind test on your assertion that maybe the noise floor masks all of this potential distortion is something that I cannot answer objectively, and no one has tested yet. So you can be skeptical, or you can believe what I say. It's fine either way. I'm just telling you my personal reactions. Oh, no, John, you asked an excellent question. The answer is we don't know. Objectively, there's a psychoacoustician, James Johnston, who has done an extraordinary amount of research on audibility and masking, and he might be able to tell us, but he might be able to not. Remember that fifth harmonic, seventh and ninth, and all kinds of intermodulation are very harsh products. So it's not just whether they're maybe masked by the noise, but maybe if a little tiny bit pokes up over the noise, whether the ear can hear it. And that's a level of psychoacoustic analysis that's that's past my job description, John. I don't know. Okay, what about keep the source file, let's say in 41, and use the internal oversampling of the plugins? No. Yes, I mean. Using the oversampling in the plugins and working at 41 is a possibility. But if you have 3 plugins in a row and one goes up and then down, then it comes into the next one, up and then down, and then the next one, maybe that cumulative SRC will wreak its audible cost as well. So I prefer, if I receive the Knoxville Jazz, we were working at 48K, which is a big improvement, I think, over 44.1. It's just like I said, when you have all these brass playing quadruple forte, you're really exercising the distortion mechanisms of these processors. So I was going to say that I like the idea of upsampling the material before it gets into Pro Tools. But now that I have the APB MooTube, I have no fears of working at 44.1 or 48 because it's an external analog processor, and I don't have to turn on my all my rack gear. We have time for a little bit. Oh, Santiago, you're welcome. You're welcome. Thanks, everybody, for listening. Yes, I have the Weiss hardware. And then he says the plugins that are based on the same code as the hardware. Do I believe that the D to A and A to D converter, if the hardware adds more to the sound than the plugin doesn't have? Okay, back in 1980, converters were real bad news. But my gosh, the last few years, converters have gotten very, very transparent. They're still audible, but what's interesting that I find, and this is another subjective judgment, is that the APB mu tube and all the APB stuff sounds more transparent to my ears than all of my analog gear. And all I can say, and Dan Dugan is going to say, oh no, not cables again and wires. But I'm going to say that I think that the 20-foot cable run between my rack D to A converters in my interface and my external analog processors in my racks takes a little bit more of a toll than the 4 mm run on a trace inside of the mu tube or inside of the APB. There's D to A converters followed by digitally controlled analog processors, followed by A to D converters, so close to one another. I think that that contributes more to more transparent sound quality. And I could be wrong. We don't have any way of proving it, but I believe that that contributes to the transparency of the APB. Yeah, you do lose some going D to A into A to D. No question. Not as much as you did in 2000, 2010. You lose a lot less. But I think that and this is my personal opinion, I think that the improvements that I get using the analog processors outweigh the losses of going D to A into A to D.